We will talk about the next distribution, which is geometric distribution. You have an assignment question. You have to derive beta 1, beta 2 for the geometric distribution. So please pay attention. So here, there are two ways of defining the geometric distribution. So I define a random variable as say number of Bernoulli trials. Number of Bernoulli trials. So again, it should be Bernoulli only. We are talking about only two possible outcomes, success and failure. How many trials you take? Number of Bernoulli trials required to achieve first success. To achieve first success. So understand this carefully. You are doing the Bernoulli trial. So you are doing an experiment which has two outcomes, and you will be repeatedly doing the experiments till you observe the first success. So let us take an example. Let me take the trial as tossing a coin. So trial is tossing a coin, and let me define success as head, observing head. Okay. Now the question is, you will keep on tossing the coin till you observe the first head. So you will toss the coin once, you got the tail. So first trial lead to tail. You will toss the coin again, second trial, again you got tail, third trial you got head. So you required two trials before achieving the first success, and we're not worried about what happens next. So this 1, 2, 3 is the possible range or the support for the variable y. Now if you are lucky, you can get the head in the first trial only. So number of Bernoulli trials required to achieve. So it could be 1. If you have got tail in the first, then you could observe first head in the second trial. Even in the second trial you have observed the tail, then the third trial you might observe head. If the third trial is also head, in the fourth trial you might observe the head. Even if that is tail, in the fifth trial you'll observe the head. So it goes on. So the success need not be always in the beginning. It could be anywhere. So your y is taking the values 1, 2, 3, 4, 5, 6. So we are talking about a variable. So till now we looked into Bernoulli, which is 0, 1, binomial, which is 0, 1 to n, and we looked into Poisson, which is 0, 1 to infinity. But here we have a geometric where x doesn't take 0, it starts from 1, provided I define my y as a Bernoulli trial, number of Bernoulli trials required to achieve the first success. But we have learned the distributions by taking the values of x from 0. So I can actually convert this and I can define x is equal to y minus 1. So if I say x is equal to y minus 1, then the support or the range becomes 0, 1, 2, 3 and so on. And then the definition of x changes. Is it clear? So this is type 1. You can take it as first category or type 1. So here the PMF of y will be P of y is equal to y is equal to P into q to the power of y minus 1, where y is equal to 1, 2, 3, etc. up to infinity, and P is the probability of success of the Bernoulli trial. So you can say what is the probability of observing success in the very first trial, second trial, third trial, and so on. Now we know that the trials are independent. So if I toss the coin and by chance I get the success or the head in the very first trial, I know the probability for that coin. What is the probability of getting head in the coin? Probability of getting head is P. So the probability of getting the success in the very first trial is P. So you can easily verify that. Put y is equal to 1. You get 1 minus 1 equals 0. Q power 0 is 1. So you just get P. And if you put y is equal to 2, you get 2 minus 1. So it is PQ. PQ square PQQ, and so on. So these are the probabilities. Now, can you tell me out of these probabilities, which is the maximum probability?
P.
Why P? Is PQ not maximum compared?
It can take only one value, which is 1.
Huh?
ಬರೀ ಒಂದೇ ವ್ಯಾಲ್ಯೂ ತಗೊಳಕಲ್ಲ ಸರ್, P1 ಆಗಿರುತ್ತೆ ಇಲ್ಲ 1.
P ಒಂದೇ ವ್ಯಾಲ್ಯೂ ಏನು ತಗೊಳುತ್ತೆ? P takes infinite values in between 0 and 1. I'm asking whatever may be your P and Q, in this case, which is maximum? Is P maximum or PQ maximum or PQ square maximum, PQ cube maximum?
PQ maximum.
Come
P
again.
maximum.
P maximum. Someone said PQ. Which is maximum? You tell me. P or PQ. How to check which is maximum?
Differentiating it, sir.
Use
And putting
common
0.
sense. What is P?
Sir, Q is a
What are P
smaller
and Q?
number less
Yeah.
than 1.
P and Q are numbers less than 1. If you multiply two numbers which are less than 1, is it greater than the number itself? Let me take say 0.2 and 0.3. If you multiply these two, 0.2 and 0.3, will the answer be greater than this or less than this?
Less than
0.2, 0.3 is always less than 0.2, always less than 0.3. So product of two decimal numbers is always lesser than the number. So your PQ, PQ square, PQ cube, all are the numbers which are less than P. So P is the maximum probability what we are observing, and the value of X or Y with respect to maximum probability is mode. So for this distribution, mode is always 1. And what does that indicate?
ಸರ್ P ಸಕ್ಸಸ್ ಅಲ್ವಾ
If you're, yes.
ಸರ್ P ಸಕ್ಸಸ್ ಅಲ್ವಾ ಸರ್? P ಯಾವಾಗ 1 ಆಗಿರುತ್ತಲ್ಲ ಸರ್?
ಬರ್ನೌಲಿ ಆಯ್ತು, ಬೈನಾಮಿಯಲ್ ಆಯ್ತು, ಪೋಸೋನ್ ಆಯ್ತು, ಇನ್ನು ನಿನ್ P ಸಕ್ಸಸ್ P ಯಾವಾಗ್ಲೂ 1 ಆಗಿರುತ್ತೆ. P ಯಾವಾಗ್ಲೂ 1 ಆಗಿದ್ರೆ ಇದನ್ನ P Q ಅಂತ ಯಾಕೆ ಬರಿಬೇಕು? 1 0. So PMF is always 1. Why do you need Y? Why do you need PMF? Why do you need mean variance? And why should I write 0 less than P less than 1? I can just say P is equal to 1. Who said P is equal to 1? Did I ever say P is equal to 1? We said success. Number of success is indicated by 1, not P. P is probability of success. ಇದೇನೋ ಒಂದು ಗಾದೆ ಇದೆ ಗೊತ್ತಾ ಕನ್ನಡದಲ್ಲಿ? ಗೊತ್ತಾ ಯಾರಿಗಾದ್ರು? ಬೆಳಗಾನ ರಾಮಾಯಣ ಕೇಳ್ಬಿಟ್ಟು ಬೆಳಗ್ಗೆ ಆದ್ಮೇಲೆ ರಾಮಂಗೂ ಸೀತೆಗೂ ಏನ್ ಸಂಬಂಧ ಅಂತ ಕೇಳಿದ್ರಂತೆ. ಆ ತರ ಇಷ್ಟು ದಿನ ಡಿಸ್ಟ್ರಿಬ್ಯೂಷನ್ ಪ್ರಾಬಬಿಲಿಟಿ ಹೇಳ್ಬಿಟ್ಟು ಇವಾಗ P1 ಆಗುತ್ತಲ್ಲ, ಯಾಕೆ ಇಷ್ಟೆಲ್ಲ ಸರ್ಕಸ್ ಮಾಡಿಸ್ತೀರಾ ಅಂತ ಹೇಳ್ದಂಗಾಯ್ತು. So this is our geometric distribution type 1, where we define Y as the number of Bernoulli trials required before observing the very first success. So your homework is computing mean and variance for this. And if possible, do MTF also. Yeah, so these are the only possible questions for the examination when they specify this particular PMF. But we'll look into all other properties, including this, for the next case, because we are very much familiar in using X is equal to 0, 1, 0, 1, 2, 3, 0, 1 to infinity, rather than just using X is equal to 1, 2. So the reason why I gave you the symbol Y is that the next geometric distribution I'll be using X, and all the results and the properties we will learn in terms of X. So that's why I just gave you in terms of Y. Now try and compute mean and variance as usual. Use the formula. Mean is expectation of Y here. It is symbol is Y. Then this is E of Y square minus E of Y whole square. So use your knowledge of the geometric progression. Geometric progression knowledge use Madi, and you should know the sum of GP for finite and infinite cases. So use this knowledge, then you can easily compute the values of mean and variance. So let me take or give you this as the fourth question of the assignment. ಬರ್ಕೊಳ್ಳಿ ಇನ್ನೊಂದು 10-15 ದಿನದಲ್ಲಿ ಕಾಲೇಜ್ ಶುರು ಆಗುತ್ತೆ ಎಲ್ಲ ರೆಕಾರ್ಡ್ ಅಸೈನ್ಮೆಂಟ್ ಇಟ್ಕೊಂಡೇ ಬರಬೇಕು ಪ್ಲಸ್ ದ ಸರ್ಟಿಫಿಕೇಟ್ ಆಫ್ ಯುವರ್ ಫಸ್ಟ್ ಡೋಸ್ ಇಲ್ಲಾಂದ್ರೆ ಕಾಲೇಜ್ ಕಡೆ ಬರಬೇಡಿ ದಯವಿಟ್ಟು. Fourth question of the assignment. This is the PMF. Compute the mean, variance, and MGF for this PMF. Next, we'll take the next is the most frequently used geometric distribution. So I'll call it as the second type geometric, where we define x as number of failures before the first success. X is equal to number of failures before the first success. So again, we are talking about the Bernoulli trial. Number of failures before the first success in repeated Bernoulli trials. Repeated Bernoulli trials. So if I define x like this, now you can see that what is the range or the subject. So you are doing some Bernoulli trials and then you are counting how many failures have happened before reaching the first success. So you are counting number of failures before reaching the first success. So again, we'll understand this. So I'll take the coin experiment. So we get head and tail. I'll take success as getting head, failure as getting tails. So I toss the coin for the first time. So this is, so we are not recording the trial. So let me take the trial number here. So trial one, I have got the result. I've got the result of the coin. Let me say H. So I have observed the success in the very first trial. So first trial alle success bandide. Hangadre ಎಷ್ಟು failures ಆಯ್ತು? I'm asking you.
Zero.
Zero. Suppose first trial ಅಲ್ಲಿ ನನಗೆ ಸಕ್ಸಸ್ ಬರಲಿಲ್ಲ. ಫಸ್ಟ್ ಟ್ರಯಲ್ ಅಲ್ಲಿ ಟೇಲ್ ಬಂದಿತ್ತು, ಸೆಕೆಂಡ್ ಒನ್ ಅಲ್ಲಿ ಸಕ್ಸಸ್ ಬಂತು. ಆಯ್ತಾ? ಅವಾಗ ಎಷ್ಟು ಫೇಲ್ಯೂರ್ ಆಯ್ತು?
one.
What is it? Before the first success. Now the first success is here because my first trial is a failure. One failure ಆಯ್ತು, ಸೆಕೆಂಡ್ ಟೈಮ್ ಸಕ್ಸಸ್ ಆಯ್ತು. ಸೊ ಸೆಕೆಂಡ್ ಟೈಮ್ ಅಲ್ಲಿ ಸಕ್ಸಸ್ ಆಗಿರೋದ್ರಿಂದ ಫೇಲ್ಯೂರ್ ಎಷ್ಟಾಗಿತ್ತು? 1 ಆಯ್ತು. ನಾವು ಸಪೋಸ್ ಸೆಕೆಂಡ್ ಟೈಮ್ ಅಲ್ಲೂ ಫೇಲ್ಯೂರ್ ಆದ್ರೆ ಥರ್ಡ್ ಟೈಮ್ ಅಲ್ಲಿ ಸಕ್ಸಸ್ ಆಯ್ತು. ಥರ್ಡ್ ಟೈಮ್ ಅಲ್ಲಿ ಸಕ್ಸಸ್ ಆಗಿರೋದ್ರಿಂದ ಇಲ್ಲಿವರೆಗೂ 2 ಫೇಲ್ಯೂರ್ ಆಗಿದೆ. ಸೊ your possible values for failures becomes 0, 1, 2. So this is the connection between x and y. So if you have defined your geometric using type 1 where you have y, then y minus 1 produces x, where x is defined as number of failures before the first success and y is defined as number of Bernoulli trials before the first success. Number of Bernoulli trials for the first success. So this is the geometric distribution which is most widely used. So the PMF of this distribution is P of x is equal to x is equal to P into Q to the power of. Can you tell me what the PMF will be? You know the PMF of y, right? PQ power y minus 1. We said y is equal to 1 to 3 up to infinity. Now we have taken y minus 1 as x. So what will be the PMF?
PQ power x.
PQ power x. Y minus 1 by x. So PQ power x. So what happens to the values of x? What is your x? X is y minus 1.
0.
By 1 to infinity. So if you do minus 1, what do you get x as?
0 into
0, 1 to infinity. So this is the support. Now why are we using this form of the geometric? Because all the distributions, discrete cases, Bernoulli trials, what we have learned, we have taken the range as 0, 1, 0, 1 to n, 0, 1 to infinity. So in order to maintain that uniformity only, we'll be discussing this distribution in detail. But in the examination, if they just say geometric distribution, you stick on to this. If they specify what is the definition of x and y, suppose if they say x is number of trials, then you have to use the previous distribution. If they say x is number of failures, you have to use this distribution and then generate the required properties. You can take the definition. A discrete variable x is said to follow Bernoulli-Bernoulli. A discrete random variable x is said to follow geometric distribution. A discrete random variable x is said to follow geometric distribution if its PMF is given by P of x equals p into q power x, comma x equals 0, 1 to infinity, comma 0 less than p less than 1, q equals 1 minus p, where x equals number of failures. It specify number of failures before the first success. Previous definition ಬರೆದು ಮಾರ್ಕ್ಸ್ ಸಿಗುತ್ತೆ, ಬಟ್ ಅಲ್ಲಿ ಬರೀಬೇಕಾದ್ರೆ ನೀವು ಎಕ್ಸ್ ಅಥವಾ ವೈ ಏನಾದ್ರೂ ಯೂಸ್ ಮಾಡಿ, ಬಟ್ -1 ಇರಬೇಕು. ಅಲ್ಲಿ ನೀವು ವೇರಿಯಬಲ್ ಡಿಫೈನ್ ಮಾಡೋದು ನಂಬರ್ ಆಫ್ ಬರ್ನೌಲಿ ಟ್ರಯಲ್ಸ್ ಅಂಡ್ ದ ಸಪೋರ್ಟ್ ಆರ್ ದ ರೇಂಜ್ ಸ್ಟಾರ್ಟ್ ಫ್ರಮ್ 1 to infinity. So this is the Bernoulli distribution, geometric distribution, where x is the number of failures before the first success. So it has one parameter, which is p. So if I know the value of parameter, now I can see, I can look into the values of mean, median, mode, variance, etc. Now can anybody tell me what is the mode for this distribution?
One.
Tabular form of the distribution. Previous distribution nange baradvi alva. We looked into the values of y are 1 to infinity, and we looked into the probabilities. Probabilities were p, pq square, and so on. So we saw that p is the highest probability, therefore 1 is the mode. In this case also, you have x. X is taking values 0, 1, so on up to infinity, and probabilities for x. When I put x equals 0, I get p. When I put x equals 1, I get pq, I get pq square, so on. So p is again maximum probability here. So value of x with maximum probability is 0. Therefore, 0 is the mode. The tabular form of the distribution, p is max. Therefore, x equals 0 is mode. Differentiate ಮಾಡ್ಕೊಂಡು mode ಎಲ್ಲ ಮಾಡಕ್ಕಾಗಲ್ಲ, because we do the differentiation technique only for the continuous case. This is not continuous.
Sir, type 1 ಗೆ Sir, type 1 ಅಲ್ಲಿ y is equal to 1 ಆಗ್ತದ?
y equals 1 ಆಗಿದಾಗ
1 minus 1 0 ಆಗುತ್ತೆ, q power 0 1 ಆಗುತ್ತೆ, p ಉಳ್ಕೊಳುತ್ತೆ ಸರ್. ಅವಾಗ ಮೋಡ್ 1 ಆಗುತ್ತಲ್ವ ಸರ್? ಅದೇಂಗ್ ಸರ್ ಎರಡರಲ್ಲೂ ಬೇರೆ ಬೇರೆ?
q power ಅಲ್ವಾ, ನಾನು y ಬರೀಬೇಕು, y minus 1 ಬರೀಬಾರ್ದು. Y is number of trials. When the first trial I am getting the success, then they should generate me p. ಏನು ನಿನ್ ಡೌಟ್ ಏನು? y equals
ಸರ್ ಮೋಡ್ ಇಲ್ಲಿ ಮೋಡ್ ಇಲ್ಲಿ 1 ಬರ್ತದೆ ಸರ್, ಅದೇ ಈ ಸೆಕೆಂಡ್ ಟೈಪ್ ಹಾಕಿದಾಗ 0 ಬರ್ತದೆ.
ಹೌದು, ಸರಿ ಅಲ್ವಾ?
ಒಂದೇ ಡಿಸ್ಟ್ರಿಬ್ಯೂಷನ್ ಗೆ ಜಾಮೆಟ್ರಿಕ್ ಒಂದೇ ಡಿಸ್ಟ್ರಿಬ್ಯೂಷನ್ ಗೆ ಮೋಡ್ ಹೆಂಗ್ ಎರಡು ಇರುತ್ತೆ?
Distribution ಅಲ್ಲಿ are you telling these two are same? Are they same? Answer me, are they same?
ಎಸ್ ಸರ್ ಸೇಮ್ ಸರ್ y-1 x ಅಂತ ಬರ್ಬೋದು. ಗೊತ್ತಾಯ್ತು.
They are not same. I have used the symbol x. X or y z ಏನೇ ಯೂಸ್ ಮಾಡ್ಕೊ ನೀನು, you have to use the definition. Here it is number of trials minus 1. I mean, yeah, here it is number of failures. So they are not same. For if they are same, why should I teach you type 1 geometric, type 2 geometric? Am I mad?
ಸರ್ y-1 x ಅಂತ ಬರ್ಕೋಬೋದಲ್ವ ಸರ್ ಮತ್ತೆ?
That is the mathematical form. That is the mathematical form. See, always you can have
ಅದಕ್ಕೆ ಅಲ್ವಾ ಸರ್ ಅವರು
mathematics. But what happens to the definition? So if I say y is equal to number of trials, and if I say y minus 1, can you say y minus 1 is number of trials minus 1? So can you talk about 0 trial, minus 1 trial and all? No. So mathematical part is different, variable part is different, statistical part is different. So you cannot just, mix up everything. So I want to obtain the second type, then I can use x is equal to y minus 1, but it is not just the direct substitution of x is equal to minus 1. So we'll look into the distribution function, we'll look into the derivative of x, we'll see whether the distribution function is continuous. So many things are there. Only then I can put x is equal to y minus 1 and I can write the distribution. So how to obtain the distribution or convert the distribution from one form to another form using the mathematical part, that is called as transformation technique, which we'll be learning in the coming semester. So there we'll see how we'll use mathematics in establishing the relationship between the distributions. That is different aspect. So for right now, just try to think logically. Don't, use mathematics everywhere. To establish a link between the distributions, I said x can be taken as y minus 1. So what I meant is that wherever you have y minus 1, you can replace it x so that you can easily remember the PMF. But that
ಸರ್ ಅವಾಗ ಎರಡು ಒಂದೇ ಅಲ್ಲ ಸರ್?
Yes, that doesn't mean that x is equal to number of trials minus 1. This is not the definition. So it changes. Okay, so in the first case, if you are asking the question, how many trials do you observe in most cases? In most cases, how many Bernoulli trials do you observe in most cases when you achieve first success? So if you are answering this question, then you say y is equal to 1. So that is the modal value. ಒಂದು ಫಸ್ಟ್ ಸಕ್ಸಸ್ ಬರಬೇಕು ಅಂದ್ರೆ ನೀವು ಸುಮಾರು ಸಲ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ರಿಪೀಟ್ ಮಾಡಿದಾಗ ಎಷ್ಟು ಕೇಸಸ್ ಅಲ್ಲಿ ನಿಮ್ಗೆ ಸಕ್ಸಸ್ ಬಂದ್ಬಿಡುತ್ತೆ. ಅದಕ್ಕೆ ಆನ್ಸರ್ ವೆರಿ ಫಸ್ಟ್ ಟ್ರಯಲ್ ನಿಮ್ಗೆ ಸಕ್ಸಸ್ ಕೊಡುತ್ತೆ. ದಿಸ್ ಇಸ್ ದ ಮ್ಯಾಥಮೆಟಿಕಲ್ ಆಸ್ಪೆಕ್ಟ್. ಬಟ್ ವೆನ್ ಯು ಲುಕ್ ಇನ್ ಟು ದ ಸ್ಟಾಟಿಸ್ಟಿಕಲ್ ಆಸ್ಪೆಕ್ಟ್, when you look in the practical case, can you always say that whenever you toss the coin once, you will always get head? No. So that's why we say it is just P. So P of y equals 1 is P, which is maximum compared to the other probabilities, PQ, PQ square and so on. So that's why we say y equals 1. That happens in most cases, not in all cases. Not in all cases. The second question is, how many failures do you observe before the success? Then we say, one day trial, very first trial alli nimge head baro chances ಜಾಸ್ತಿ ಇದೆ. So one day trial alli nimge heads baro chances ಜಾಸ್ತಿ ಇದ್ರೆ ಎಷ್ಟು failures ಮಾಡಿದೀರಾ? 0 failures ಮಾಡಿದೀರಾ? Same question, same answer, logic is different, but mathematical value is different. So there you said x is equal to 1, here you are saying x is equal to 0. Now the reason why I didn't use x in both the cases, that you will always end up getting confusing. You already P ne confusion ಆಗ್ಬಿಟ್ಟಿದೆ, ನಾನು ಎಲ್ಲಾನು x ಅಲ್ಲೇ ಹೇಳ್ಕೊಟ್ಬಿಟ್ರೆ ನಿಮ್ಗೆ ತುಂಬಾ ಕನ್ಫ್ಯೂಸ್ ಆಗುತ್ತೆ ಅಂತ I used y. And to remember the PMF, I gave you the logic. You can think that x is equal to y minus 1, which is mathematically valid, but not in terms of the definition of the variable. As the variable changes, the properties definitely changes. The variable changes, probably property definitely changes. Okay. Fine. So look into some books, some YouTube videos, and understand them and make the things clear. Okay. Now we'll look into the mean variance, then MGF, and if possible, we'll see the recurrence relation also. So we have the PMF of the geometric, which is 3q power x is equal to 0, 1 to infinity. Now mean is expectation of x minus expectation of x, which is defined as summation of x into px over all possible values. Here the possible values are 0, 1 to infinity x into pq power x. So first the PMF are the very famous. Okay, so expand this sum. Okay, you have p a constant 3 of x, so I can take that outside, and then now I can start substituting the values from x equals 0 to infinity. So when I put 0, I'll get 0. When I put x is equal to 1, I get q. When I put x is equal to 2, I get 2q square. Then I'll get 3q cube, 4q power 4, and so on up to infinity. Now we have to try to obtain the sum for this number. So there is a very simple way of obtaining the sum where it involves a geometric progression like this. Here only the geometric part is q square q, and this is the arithmetic part. So this series is called as arithmetico-geometric series. You remember, and I can easily see there is a formula also to obtain the sum of the arithmetico-geometric series, but you know it is very much difficult to remember. Not that difficult, but I will tell you an easy way to obtain this. So here, everywhere I have q common, so I can take that q also outside, then I'll be left with 1 plus 2q plus 3q square plus 4q cube plus etc. up to infinity. Okay, so let me call this as sum. Yes. So the title marked that s is equal to 1 plus 2q plus 3q square plus 4q cube plus etc. Okay. Now obtain qs. For s, you multiply by q. So when you multiply by q, you'll get q plus 2q square plus 3q cube plus 4q power 4 and so on. Okay. Now do the subtraction. S minus qs. So have 1 as it is. Now you can just look into the terms which have the common algebraic term. So have 2q, 3q square and so on. Now 2q minus q is q. 3q square minus 2q square is q square. 4q cube minus 3q cube is q cube. So I'll get q power 4, q power 5, q power 6 and so on up to infinity. So your s minus qs has produced a geometric series. So arithmetico-geometric has now become geometric. So your s into 1 minus q. And this is your GP, purely GP, infinite terms. So what is S infinity of a GP? Sum of infinite terms of a GP. That's starting from the first term A, then you have AR square, etc.
A by R minus 1.
A by
R minus 1.
R minus 1, provided your R is greater than 1 And if r is less than 1, then the sum becomes a by 1 minus r. So here the common factor is q, and we know that q is less than 1. Therefore, the denominator will be 1 minus q. A is the first term is 1. So everywhere you have 1 into q square, 1 into q. So this will be a by 1 minus q. So this s is equal to 1 minus q is nothing but p. So I can write this as 1 by p square. So this is our s. So we have pq 1 by p square. So the mean of geometric series is q by p. Did you get it? And the same way methods are used to derive e of x square, e of x cube, e of x power 4, and so on. Search for that formula, sum of arithmetical geometric series. To get a formula, try to apply it and reduce that also. But if you feel that you can't make it hard to remember the formula, then you can learn this technique. So this technique produces the sum for cases where you have terms involving 2, 3, the powers, arithmetical geometric series especially. So this is the mean of the distribution. Now try to obtain the variance. Variance try ಮಾಡಿ ಇದೇ ತರ e of x square ಬರ್ಕೊಂಡು I'll give that as homework. If not, I'll do that in the next class. Now we'll look into the recurrence relation between the probabilities and we'll see the end here. So first one, between the two successive probabilities. So we know how to derive it, right? You will define probability for x and you will define probability for x minus 1. Previous probability. So it will be p into q power x minus 1. So if you divide them, you will get the recurrence relation. Divide and simplify. So get pq power x by pq power x minus 1. So p get cancels, q power x by q power x minus 1 produces q. And we also learned that, right? Already table ಬರ್ದಾಗಲೇ ನಮ್ಗೆ ಗೊತ್ತಾಗೋಯ್ತು next probability ಹೆಂಗ್ ಬರ್ತಾ ಇದೆ ಅಂತ. ಈಗ x is equal to 0, 1, 2. For every previous probability, you multiply q, that generates the next probability. Pq into q, pq square. Pq square into q, pq cube. So the recurrence relation is also telling that pq probability for x is same as q into previous probability. So every time without using the PMF, if you want to generate probabilities for a list of values of x, just multiply q for the previous term and produce the successive probabilities. Next, if you want recurrence relation between two frequency terms, then for the frequency terms you have to multiply. This derive ಮಾಡಬೇಕು ಮತ್ತೆ ಬರೀ ಇಷ್ಟೇ ಬರಿಬೇಡಿ. So let me call this as 1. So multiplying by n on both sides, I get n into p of x is equal to x is equal to q into p of x equals x minus 1 into n, which is the theoretical frequency that gives you the required form. So you have p of x equals x is equal to q into p of x equals x minus 1. So this is the recurrence relation for two successive frequency. This is the recurrence relation for two successive probability terms. Now we'll see whether pq power x actually produces a total probability of 1. So verify whether p of x equals pq power x is a PMF. So question will be like, say, define geometric distribution so that it is a PMF. You can define either the y form or the x form. So to verify, we know that a probability function is a PMF if the total probability is equal to 1. Total probability is equal to 1. But we have the PMF now as PQ power x with the support or the range x equals 0, 1 to infinity. Now consider the sum over all values of x. Sum over all values of x and see whether it produces 1. Now p is a constant because it is independent of the term x, so I can take it outside. And now I'll start substituting x equals 0, 1 and so on. So when I put x equals 0, I get q power 0, q power 1, q power 2 and so on. So it is purely a geometric series with a equals 1 and r is equal to q. So sum to geometric series is a by 1 minus r, which is 1 by 1 minus q. 1 minus q is p. So they get cancelled and we get 1. So the total probability is coming to 1. Therefore, you can say PQ power x is a PMF. Now you try the same for the function form of y. PQ power x minus 1 or PQ power y minus 1. ಬರ್ಕೊಂಡು ಅದು PMF ಆಗುತ್ತೆ ಚೆಕ್ ಮಾಡಿ ಅದಕ್ಕೆ ಮೀನ್ ವೇರಿಯನ್ಸ್ MGF ಮಾಡ್ಕೊಳ್ಳಿ ಕೇಳ್ಬೋದು ಎಕ್ಸಾಮ್ ಅಲ್ಲಿ ಯಾವ ಫಾರ್ಮ್ ಮಾಡಿ. Next, we look into the MGF of geometric distribution. What is the definition of MGF? What is the definition of MGF? How do you define MGF?
Expectation of e power.
Expectation of e power px. That is your MGF. And by the definition of expectation, that will be summation over all possible values of x e power px into probability function. Here x is taking value 0, 1 to infinity e power px into pq power